Hello and Assalamualaikum. My name is Ahmad Sofi Bezanjuri Arifin. We are from Group 3, Section 9. And today we will be presenting our assignment project for Engineering Mathematics 5, which the title is Statistical Analysis on Data of Temperature and Humidity Detected by Electronic Sensor. Introduce my group members, Muhammad Afiq bin Ahad Rumisam, Muhammad Amir Ridwan bin Muhammad Ghazali, Muhammad Zikri bin Hamim, and me myself, Ahmad Sofi Bezan Zuri Arifin. So I'll be presenting for the SPSS simulation for our project. First, we put our data, which is X and Y, independent variable and dependent variable, into the table here. And after that, we set for each of them with numeric type. So for the first step, we analyze the data using descriptive statistic and use frequency, and we put both of it into the variables that we want. And for the statistic, we set the median, mean, mode, sum, standard deviation, variance, minimum, maximum, and SE mean. And after that, we continue and we press continue and we press OK to obtain the result, which is like this. This is the frequency for statistic, and we can see we get the variance, standard deviation, median, and all the data that we want. Then this is the frequency table for each variable, which is temperature and humidity. And after that, for the graph, we press the graph here and we use legacy dialog and plot a simple scatter. And for the simple scatter, we put each of them into Y and temperature into X axis and use the title. And for the graph, we can see that we get this kind of graph. And after that, to achieve the regression line, we can set from here, which is we set it at fit line at total, and we can get this straight line after we achieve the regression line. So to achieve the regression, the correlation, we use analyze, regression, linear, and set the dependent and independent. And for the statistic, we select the R-squared change, descriptive part and partial correlation, and collinearity diagnostic. We choose all of it, and then we get the table for each of the data, which is correlation, variable enters, model summary, the ANOVA table, and coefficients, and also the collinearity diagnostic. The last but not least, to analyze the last step, which is sample test, we use analyze. That means we choose one sample t-test and we put the test variable that we need, and we press OK. After that, we will get the table is shown here, which is t-test, one sample statistic, and the table for one sample test. And that's all for SPSS simulation.
Assalamualaikum, my name is Muhammad Amir Ridwan bin Muhammad Ghazali. So for this part, I'm going to present the result and discussion for 4.2 A and B. So basically in this slide, you can see that this is the result that was analyzed by using the descriptive statistic in the SPSS. So basically the table shows that the mean value for temperature or independent variable is 24.40 and humidity is 19.98. And then the value for standard deviation is 7.691 and 5.158 for the humidity. And then the result in the that we acquired from the software being compared by the manual calculation. So basically this is the manual calculation for each variable x and y. So basically we have calculated the mean value. For the x, we get 24.40, which is the same as in the software. And then the variance is 53.825. And then for mean of dependent variable, which is the y or humidity, we get 19.98% for the mean, which is the same value. And then for the variance, we get 22.87 watt, which is the same value as in the software. And then we have the scatter diagram and the regression line. So in this slide, it shows the graph for scatter diagram for humidity versus temperature, which is the humidity is in y-axis line and the temperature in x-axis line. And then by using the software, we can get the regression line with the equation of 34.82 minus 0.61x.
Assalamualaikum, I am Muhammad Afiq bin Ahal Nisam. My metric number is AE190052 and I will explain about 4.3, 4.4 and 4.5. So 4.3, we have to find the simple linear regression model. We have to assume a linear relationship and use the least square. So using all of this equation, we can find the beta 1 equal to negative 0.608. Here temperature is 0.608 and the constant we can get using this equation, which is 34.818. As we can see in the table here, it is the same. So the linear regression model is y equal to 34.818 minus 0.0608x. So for 4.4, we have to check the significance, which is 0.05 of the simple linear regression model in previous 4.3. So based on the table, the equation of the line of temperature to predict the humidity is here negative y equal to negative 0.608x plus 64.818. So based on the value of B from the under standardized coefficient. Next, the value of the B from the temperature is the slope. Here, negative 0.608 and the constant in the intercept of y is 34.818. To determine the line is whether it is significant or not, we can see the value of significant is 0.000, which is it is less than 0.05. So we can say here that this is significant. So next is 4.5. We have to interpret the meaning of intercept and slope in our problem. So the regression line equation is y equal to beta 1x plus beta 0, which is consists of independent and dependent variable. So beta naught is represent the y-intercept and beta 1 indicate the slope of the regression line. So the independent variable is the value of temperature in Celsius, while the dependent variable is the value of humidity, H in percent. So in this project, we can say that the regression line equation is y equal to negative 0.61x plus 34.82. So we can, that's all from me. We can continue to 4.6.
And Assalamualaikum. So next, we will be testing the hypothesis. So first is whether the slope is equal to 1. The null analysis given is beta 1 is equal to 1. So for the hypothesis, we will use the formula here and the step here to determine the t table and also the t slope for this variable. So for the t slope, we get negative 21.2738. Hence, we can reject the null analysis, which shows in the t slope is less than negative 1.984 that we calculated on the t table. By that, we can conclude that the slope beta 1 is not equal to 1. So for the hypothesis whether the intercept is equal to 0, the given null analysis is B0 is equal to 0. So it is same as above. We will need to calculate and use the step. Hence, we will get the t-intercept is equal to 47.641. So we can reject the null analysis HO since the t-slope is more than 1.984 that we calculated above on the t table. By that, we can conclude that the intercept VO is not equal to 0. Actually, for the value for the t-slope and the t-intercept, we can refer to the table on the coefficient table here for the t value. So we can see that the value is almost equivalent. Maybe it is due to the small error in calculation or on the usage of the decimal. So next, we will compute the coefficient of Pearson correlation. So the Pearson correlation is defined as a measure of strength and direction of association that exists between two variables measured on at least an interval scale. So here are the formula for calculating the Pearson correlation. So we get negative 0.907. So it is same as in the table for the temperature. And lastly, we will compute the coefficient of determinations. So this coefficient is to determine how one can be making prediction from a graph. So here are the formula for the coefficient of determination, and we get 0.822 value for the coefficient of determinations. Hence, by that, from the R, we got the strong linear association, and from the R square value, we got 82.2% of the total variation is explained by the regression line using the independent variables. So that's all for from our group. So thanks for the watching.